Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth, while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will talk about the twin paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which lead to the brother in spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanos, which is about 10 light years away from the solar system. And the spaceship is moving in the speed of the 80% of the speed of light. That is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. That is equals to 2 times 10 divided by 0.8, and the final result is 25 years. The twin in the spaceship actually travels back and forth from Earth to the star Epsilon, and returning then to Earth. So it travels back and forth, and the total distance that he will pass is actually 2 times the distance between Earth and the star epsilon, that is 2 times 10 light years, that is 20 light years, and it travels in the speed of 80% of the speed of light. So in total it will take him 25 years from the point of view of the twin that is on Earth. Um, and according to Lorentz transformation, the time measured by twin in spacecraft is T spacecraft equals to T naught times root of 1 minus v square divided by c square. That is equals to 25 times root of 1 minus 0.8 squared, and the final result is 15 years. So because of time dilation, the twin that stays on Earth is watching his twin brother that is traveling in the space in the spacecraft in very high speed. And that is the reason that the twin on Earth actually sees that the time dilation of his twin brother that travels in very high speed. So the total time that it will take him to go back and forth from Earth to the star epsilon and back to Earth, it will be only 15 years, because of the fact that the twin in space travels in very high speed, and there is the time dilation for him, and so it will take him only 15 years to go back and forth. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star epsilon in Eridanos are moving across it at the speed of 80% of the speed of light. That is to say, 240,000 kilometers per second. As a result, the distance between them shrinks according to the Lorentz transformation, so the distance it must travel is L spacecraft equals to L naught times root of 1 minus v square divided by c square equals to 10. 10 is 10 light years from Earth to the star epsilon, from the point of view of the twin that stays on Earth. 10 times 1 minus 0.5 squared. Actually 0.8 is the v squared divided by c squared. So the total distance between the twin that in the spacecraft and the star epsilon shrinks from 10 light years to 6 light years only, and because the length shrinks at the speed of 80% of the speed of light, the round trip will take in total T spacecraft equals to 2 times L spacecraft divided by V equals to 2 times 6 divided by 0.8 equals to 15 years. So because of the fact that the distance between Earth and the star epsilon shrinked to 6 light years, from 8 light years it shrink to 6 light years, the total distance back and forth from Earth to the star epsilon and then from star epsilon to the Earth will be 2 times 6 light years, that is 12 light years, and in the speed of 80% of the speed of light, it will take in total only 12 divided by 0.8, that is in total 15 years. So therefore the twins effectively agree that the twin in the spacecraft, in the spaceship, will be younger in 10 years when they meet again. In terms of the twin that remains on Earth, is due to the effect of time lengthening, and in terms of his traveling twin, due to the contraction of distance. The distance between Earth and the star epsilon contracted from 8 light years to 6 light years. So in total he had to travel the distance of 12 light years, and in the speed of light it will take him only 15 years, because it is 12 light years, that is the way, divided by the speed that is 80% of the speed of light, that is 240,000 light years per second, and it, in total is 15 years. Okay, thank you very much.